Welcome to the next example. Here we're looking at the reciprocal function 1 over x. So we have our f of x plus h minus f of x all over h. Okay, I'm going to bring that 1 over h out front again. And we'll have a 1 over x plus h minus 1 over x. Let's get a common denominator this time. So let's see. We have that 1 over h out front times common denominator here will be x times x plus h. Right, there's no factors in common with these denominators, so just multiply them together. First fraction, multiply top and bottom by x, minus second fraction, multiply top and bottom by x plus h. Right, so just for emphasis, right, this minus sign is the same as that minus sign right there. So now in the top, we see these x's reduce out nicely. Now this is the part where the numerator, you have to be careful. There's this negative sitting out in front of the bracket. So the top is a negative h now over hx times x plus h. These h's reduce out. And remember, in the numerator, now we have a negative 1 over x times x plus h. Let's do the alternative form, the typical difference quotient. This is where we have f of x minus f of a all over x minus a. All right, so now what do we want? Let's bring that 1 over x minus a out front, and we'll have a 1 over x minus a 1 over a. There's our f of x minus f of a. Now, common denominator, let's do that. So we have this 1 over x minus a out front times common denominator would be ax. Now, the first one, the first fraction, we would have to multiply top and bottom by a. So you get a over ax minus, again, same minus sign as before. And the second one, we'd have to multiply top and bottom by x. So you get a minus x in that numerator. Now, these look really close related. The numerator and denominator factors, they're a little bit off. So what you can do to see that really they're how close related they are, you can factor a negative out of the top and you'd be left with x minus a all over, and we have ax times x minus a in the denominator. And now these factors can reduce out because they're identical, and we get a negative 1 over ax. All right, now the next example, we'll step it up a little bit more.